In the previous video, I ended with showing you that sodium will typically create a +1 charge because it wants to lose that outside electron so that its outermost energy shell has 8 electrons. Let's look at another example of this. Whoops, excuse me. So right now I want to look at oxygen, which has 8 protons and 8 electrons. Sorry about that. So oxygen typically has 8 protons, 8 electrons. So here is oxygen with its very first energy level, and it has 2 electrons in its inner energy level. And then in the outermost energy level, it has 6. Notice I did the singles before I paired them. That goes back to Hund's rule. So now I've got these 6 electrons in the valence shell. So oxygen's regular valence number is 6. Now remember the octet rule, oxygen really wants to have 8 electrons in its outermost shell. So the thing to remember is, all right, is this oxygen more likely to lose all 6 of those electrons to have a full shell? And remember that first shell with just the 2 electrons is a full shell. Or is it more likely to just add 2 more electrons? And the answer here is it is more likely to add 2 electrons. So now instead of 8 protons and 8 electrons, it has 8 protons and 10 electrons. So now this oxygen has a charge, and the way we would write that is O2+. And it has, it has O2-. And the reason for that, it has 2 more negatively charged particles than positively charged particles. So when you have a very stable oxygen like this, it has a charge of -2. Okay. Now, this is called an ion. Ions are charged atoms. So anytime that you hear me say an atom, you can typically assume that I mean a neutral atom. If I say an ion, well, that's talking about a charged atom. Now, there's 2 different types of ions. There's a cation, which is positive, and anions are negative. And the easiest way, I think, to remember this is this T in cation kind of looks like a plus sign, therefore it is positive. So you do need to remember this detail about ions because when we look at periodic trends, we're going to look at ionic radius, and for that you really do need to remember how to identify which atoms are going to form cations or anions. And let's look back at our periodic table again, just as an example. So an easy way to think of this is, remember we talked about valence electrons, and this column here, this group has 1 valence electron, this group has 2, and then in the P block over here, this group has 3, 4, 5, and so on. Now, realize that when we talk about ions, this very final column, these are the noble gases, they will not form ions. They are completely happy. They're not going to add electrons. They're not going to lose electrons. They are quite satisfied with the number of electrons that they already have. So they don't form ions. This first column here, since it has 1 valence electron, it is much more likely that they will lose that 1 valence electron in order for them to have an electron configuration similar to a noble gas. That's essentially what's happening when it's either losing or gaining electrons. So here, all of these elements, hydrogen, lithium, sodium, potassium, all the way down, they are much more likely to form a +1 charge because they will lose an electron. So if rubidium loses an electron, it has 37, and then what if it ends up with 36? It's going to look more like krypton. And so now it's happy because it has a completely full outer shell. But it does have a positive 1 charge. All the elements here in the second group are going to have a positive 2 charge, right? Because they're going to lose 2 electrons to be more like a noble gas. And all of these in the D block and the F block, they're also most likely to just lose 2 electrons. However, we're going to talk a lot more about these elements and the differences between them and some of these others. Looking at the second to last column, the fluorine group, they're so close to being like these noble gases, they just need 1 more electron, just 1 more. So instead of chlorine losing 7 electrons to be like neon, it's much more likely to gain an electron and be like argon. At least as far as the electron configuration goes, it would be like argon. So if chlorine adds an electron, and remember electrons are negatively charged, that chlorine would now have a -1 charge. So all of the elements in this second to last column, in this group 17, they're going to have -1 charges. This oxygen column, they're going to have -2 charges because they're likely to gain 2 electrons. Nitrogen's group here, likely to gain 3 electrons, so they're going to be -3 charges. So phosphorus would have a 3- charge, arsenic, antimony, a lot of these. Okay, and we'll talk about the different colors here and what that means for their likelihood as far as what are they going to give up. Maybe they don't want to give up any electrons, maybe they want to add electrons, and so on. This carbon group, this is going to be a little bit different. Carbon is not really interested in giving up electrons or gaining electrons. It has 4 valence electrons, and later on we'll talk about a special kind of bonding that happens when an element or an atom doesn't really want to give up or add any electrons or steal them anyway. Here you've got boron's group. I know it doesn't seem like they're very close to one another, but these elements here on the left, they're going to lose electrons. So is boron's group. Boron only has 3 valence electrons. It is much more likely to lose those 3 valence electrons rather than gain 5. Okay, so just kind of remember that these groups all over here, 1 through about 13, they're going to lose electrons. These guys here from 15 through 17, they're more likely to gain electrons and become anions. These on the left, they're going to be cations because they're going to lose electrons. Therefore, they will be positively charged atoms, meaning they are cations. Start getting used to using these words because we're going to be using them the rest of the semester. Cations, anions, positively charged, negatively charged, and valence electrons. You need to know all of those and be very, very comfortable. So start trying to explain those terms to your friends, your parents, your pets. I don't care as long as you are comfortable with them. Okay, that's all for now.